Basically, steel has been used for some of the most memorable and the most iconic buildings, structures across the world. They have been symbolic, they get etched in our memories. It has also been used as a path-breaking material 100 years ago, Empire State Building, riveting 100 floors high, or as innovative infrastructure solution. Now all this has already been done and executed 100 years as of today. And more recently and contemporary examples you have of clearly architectural innovations, engineering marvels, and so that's where globally the steel industry has complemented the creation of architectural and engineering landmarks. Metal, steel in India has been used far more wherever India needed to build something that would last for many centuries, like the Ashoka pillars, the Howrah Bridge. Of course, the English designed this, but yes, these are Indian. And more recently, the cable stayed bridges over the ceiling, and in the more recently closer to Gujarat, the Narmada Bharuch bridge as well. And metal in many forms as one of the landmarks in the world, the Sardar statue of unity. So as architects, structural designers, clients and regulators, one should continuously strive the use of new materials, new technologies, efficiently, sustainably and innovatively. I think this is where we should all focus, no matter what our background is. And for the past many decades, HCP has done that. So I will just draw quickly from the examples of some of the projects designed by us and put things in a perspective that when we talk about steel or any building material, it's not the whole building that needs to be constructed out of that. It can be used innovatively, it can be used ingeniously, efficiently. So I think one of the first innovative solutions we required to be done in steel was we were designing a large manufacturing facility for Arvind and Mayur Bhai from Proflex, who's sitting here. At that time just got this new machine which manufactured the shell roof, and the client was pushing us for time. So while the entire building was set up in the normal brick mortar method, we had this 20-meter span, 70 meters length structure, which was done in I think about 2 weeks of time, and done in steel. The entire equipment came to site. They manufactured the panels, they interlocked them, they lifted them onto the eaves, and this thing was put in place in about 2 weeks. We also did for the '87 World Cup the Eden Garden Stadium's canopy. So it was again steel being the preferred material because of its obviously lightweight, long span properties. And that time Mr. Dalmia had approached us and said that we wanted to do this fast. So again, steel was the most preferred solution. One thing that we kept on encountering, and this is something that we can all put in another perspective, is that whenever we talked of steel, there was always a designer-vendor gap that we used to, either the material was not available, or the fabrication was not up to the mark, or there were certain constraints that we had to deal with. But it was only the necessity or the push from our side that sort of ensured that we did a good job. Unlike many materials of Indian construction industry, steel you get most of the things prefabricated, so you need to detail and design immaculately, so that what you get on site manufactured in the factory it meets your standards and meets your dimensions. Another thing that we did for a large pharmaceutical facility for Claris was we were asked to do a series of manufacturing plants. The central square block is 100 meters by 100 meters, just to give you a scale of the facility. And the column grid, the RCC column grid was ranging between 18 meters to 26 meters, 27 meters. So while the majority of the facility was ground floor, there was the clean room area where the actual injectables were going to be manufactured, which was double floored, and all the utilities sat on the first floor. So we designed these trusses, structural steel trusses, two reasons. One, easy and efficiently spanned at 27 meters, and two is that all the utilities, piping and ducting could pass through the trusses. So while what you see, on the utility floor is a whole, mesh of ducting, cabling, and piping, on the floor below you have a class 10,000 clean manufacturing facility. More than 5,000 tons of structural steel has gone in, and you can't see any of it when you actually visit the building. You don't have to use steel large scale. So as a designer, we've always tried to innovatively find uses for steel. And then when we designed this RCC building, which won a world design award, there was a double height entrance area which needed to be weatherproof. So we did got a weather screen done there. It basically shielded the sun, broke the rain, and we got an artist to design that screen here. Another project that we were doing, we did the new campus for the Indian Institute of Management, where again, there were large concrete spans that needed to be dealt with, and we thought that why not use structural steel as a component, a very important component of the campus. So we used, wherever there were large spans, we used sculpted trusses. So the trusses were not designed by structural engineers, they were designed by an artist, and then the structural engineers only fine-tuned that truss design. So we had a whole variety of spans and a whole variety of truss sizes, but which make a very important and memorable component of the campus once you visit it. Small things like this 8-story building, again in concrete and glass, where the service core was concrete. We had the 8-story fire escape also designed in steel. Pre-engineered building, you hear a lot of this nowadays. I'm talking about back in 2000, where pre-engineered buildings was just sort of getting pushed into the industry scenario. And again, one of our clients approached us saying that they had got a solution, but they were not happy with it, and so we said that we don't want to do something that is as non-aesthetic as this. So we took the PEB design, we remodeled it. Using the same components, we came up with a more aesthetic, a more innovative, and in the end, a more cost-effective solution than the original proposal, using the same PEB components. And it was constructed in record time and much cleaner looking than the original PEB. So as a designer, I think we can also push the limits of what is available in the market, and make sure that we come up with something that is good to look at as well as being efficient. We've also done a lot of custom design with steel structures. One was there was this large solar park, India's largest solar park at that time, which was coming up in Charanga, in desert area. And the Honorable CM at that time wanted a viewing deck where he could bring the visitors and see the whole solar park. So there was an observatory deck that needed to be constructed, again to be done in 2.5 months, and very quickly designed modular components which could be stacked up on each other. And this is the picture of the site with the tower standing there. And so it was all, of course, the central core had just got one lift, viewing decks on various levels, and that's a view of the completed tower. So everything was naked, so all the pipes, lights, conduits, everything was managed within the structural steel frame. And it was a very beautiful, elegant, efficient structure put up in about 2.5 months. Another one we did many years ago in 1989 for a cardboard manufacturing facility. Again, the entire facility, natural light, ventilation for a packaging manufacturing industry. And more recently, we did, that's about 7-8 years ago, manufacturing facility that manufactured bottling plants. So large, the client came to us with a unique requirement saying that we don't, usually in our factories, the pigeons sit on the trusses. So what to do, and they had to manufacture in the food grade stainless steel, so it would get stained by the droppings of the pigeons. So taking that idea, what we said was that why don't we put the trusses outside, stick the roof on the inside, and that is precisely what we did. Again, encountered a lot of fabrication and industry, manufacturing support. We couldn't find the right people to do the jig for the trusses because one truss needed to be repeated about 80 times. And precision welding, cutting, all of these were challenges as recently as 2010. And then finally we managed to put this up, and the roof gets stuck on the inside. It is more efficient from the rainwater and the wind gusts during cyclones. The roofs won't fly off. It also gives a fantastic clean surface on the inside. No pigeons, no place for pigeons to sit anywhere. We also did some, the structural steel supports take the 26-ton gantries spanning again 20 meters. 100 feet length. The detailing for the lighting and the skylight and the stack ventilations was also done. And you get a clean shop floor. Natural light coming from between the two sheds with ventilation. And the factory looks elegant from the outside also. So it's not something that it's a shed that is making these large machines. These large drawer windows were taken where 40-foot containers could go inside the factory, and the entire equipment weighing more than 100 tons could be loaded onto the container itself. And this is the view from the front lawns. These large north lights take in the natural light, so we have this whole thing as placed. Again, only building components is not something that that should restrict your thoughts. This is something that I did in the year 2002 for P&O Ports, who was a large port operator. Now they've been absorbed by DP World, Dubai Ports. And we were asked to design the operations control center in the Chennai container terminal. It was a simple set of buildings, the operations control center, which overlooked the entire container terminal. So that's that concrete building with the round walls that you see, 7-story building. Looking at the container terminals from where all the container management happened. The entry gates, the canteen block, and then the parking. So the north side, which faced the container, was completely glass because the people needed to look at the the containers being handled on the port. But the south side was completely blank because this was intentionally kept this way because south side Chennai, lot of heat, so we kept all the services on the south side architecturally in terms of the layout, which gave us a blank facade. So we said, what do we do with the blank facade? So we said we'll use a large mural, and at that time this was also one of the largest stainless steel mural installations in India. So 6 stories and about 30 meters wide. We got an artist to design this. The next challenge was to how to get this fabricated. So this mural used both structural and mild steel components and stainless steel. Stainless steel primarily because of the vicinity to the sea, so it doesn't get corroded. And then the artist came up with this fantastic thing. The challenge was that he had designed the mural which was curving in both the directions. So it was curving from top to bottom, it was also curving from east to west. So we converted the artist's rough model into a set of drawings, got precise measurements, and then we scouted in Chennai. We couldn't find anybody in Chennai who was up to getting this manufactured. So we came down to Ahmedabad and we said we'll manufacture the mural in Ahmedabad and we'll then transfer it to. So basically then the mural needed to be designed in a set of components. So there were 6 sets of components. One was the base plates, which were fixed, which were not adjustable, so they came onto a grid onto the concrete facade. Then there was the horizontal pin, which was adjustable. So you could, if there was any variation in the then there was the central block on that horizontal pin, which was the pivot, which allowed the adjustment in the top-bottom direction, and as well as it would slide along that horizontal pipe for any horizontal And then there was the cantilever pin, which allowed for the adjustment with the distance from the wall. So we had prepared a kit of parts that allowed adjustments in almost 360 degrees with the prefabricated. And then we of course tested it. This was my friend Kaiser, who owned the manufacturing facility here. And finally we installed it in this thing. At that time, the graphic images were printed on large sheets, and then they were put on laser cut, these were pasted on steel panels which were laser cut. Just to give you a sense of the scale, that lower left, the man you see standing there, and the badge, that is the coolie's badge that you see 3011. So that's the scale of the mural. Consisted of more than 4,000 parts, of which more than 450 steel plates, stainless steel plates. And because the construction was going on in full speed, the entire kit needed to be airlifted, and it was installed in 9 days on site. So that is also something that was innovatively used, and that's what the completed building facade looks like. And now, more recently, sports is another thing. So sports arenas is also something that now, with Indians performing well in many other sports other than cricket, sports, I mean, the young generation is both for physical fitness as well as a career option. Sports is seriously looked at. So we're doing a couple of these sports arenas also, which are also in steel, ground plus one structure. And these will take in multiple courts. As you can see, it's a simple truss frame, but once finished, it will be a very elegant, very classy, almost a airport-like structure. Most of the areas are also air-conditioned, flexible, so you can have sports, you can have seminars. So I think, to summarize, as architects, structural designers, clients or regulators, it is our responsibility to continuously strive to use materials, steel of course, but any other materials efficiently, sustainably and innovatively. As manufacturers, suppliers, construction agencies, this is the other side from where I sit, it is our responsibility to ensure high adaptability. Usually we get, this is what I have. You take it or leave it, and most of the people leave it because it doesn't meet the requirements. So adaptability, availability, and quality. I think quality is something that as a country we need to wake up to. It is completely, whether it be our roads or whether it be our buildings, we cannot have. So anything that is good quality, you will find that mostly it is not manufactured. It's time to change that story. I think as a group, designers, vendors, manufacturers, suppliers, we need to break traditional myths associated with the materials. So steel is expensive, steel nahi milega, crore ho jayega. So all those traditional myths we need to break. The world has broken it 100 years ago. Try to think out of the box. Most of the places we have tried to push where innovatively we can use different materials. Be explorative, creative in designing, manufacturing and constructing. Create attention to detail and quality, and ensure practicality, constructability and ease of maintenance. Maintenance is also something that, for example, that Chennai container, all the MS was hot dip GI, then again painted with anti-corrosive paint, and then the stainless steel was again anti-corrosion grade stainless steel. So that's all, and I hope we set the tone for the rest of the day. Thank you very much.